All right, suppose I tell you the universe had a beginning. Bang! Everything pops into existence. Time starts, space starts, matter starts. That's the story everybody knows, and it sounds very tidy. A little too tidy, actually. Because the moment you accept it, you've quietly agreed to something very strange, that there was a time when there was no time. And if that sentence didn't make you squirm just a little, you're not thinking hard enough. Let me put it another way. Imagine I walk up to you and say, I was born before I was born. You'd look at me like I finally lost it. Yet when we say the universe began with the Big Bang, we're saying something just as peculiar. That time itself had a starting point, but somehow that starting point isn't inside time. It's like trying to point to the edge of the earth and asking what's north of the North Pole. You can say the words, but they don't quite mean anything once you push on them. Here's a little experiment you can do in your head. You don't need any fancy equipment, just curiosity, which is much cheaper. Close your eyes and imagine rewinding the universe like a movie. Galaxies rush back together, stars unburn, atoms politely reassemble into simpler forms. Everything gets hotter, denser, faster. Eventually, you reach what we call the Big Bang. Now ask the obvious question that every child asks and every adult is trained not to. Okay, and then what? People will tell you, there is no then. Time started there. But that's not an explanation, that's a warning label. It's like saying, do not open, contents undefined. You're allowed to say it in mathematics, but your intuition won't let you rest. The trouble is that our brains are built to think in causes. Something happens because something else happened before it. You hit the cue ball. The 8-ball rolls. You don't accept a pool table where balls just leap into motion for no reason at all. So when physics comes along and says, everything happened, and there was no before, your mind rebels, and it should. That rebellion is not stupidity, it's the engine of understanding. Now here's the paradox that hooks us. The Big Bang works astonishingly well as a description of the early universe. It predicts the expansion of galaxies, the cosmic background radiation, the abundance of elements. It's a terrific calculation machine. But when we mistake a good calculation for a complete story, we get into trouble. The equations describe how the universe expanded from a hot, dense state. They do not, by themselves, tell us that this state was the absolute beginning of everything. That's an extra assumption we like to smuggle in because it feels dramatic and final. Let me tease you with something uncomfortable. Physics has never actually observed a beginning. What it observes are limits, places where our current ideas stop working. When an equation blows up and gives infinity, that's not nature shouting, how? That's nature politely informing us that we're using the wrong tools. Infinities are not facts, they're confession notes. Think about temperature. If I tell you something has an infinite temperature, you wouldn't rush to publish it. You'd say, well, I must be missing something. The same should be true for an infinite density at the Big Bang. Yet we've gotten so used to the story that we stop questioning it. Here's another way to feel the problem. Take a ruler and imagine measuring time the way you measure distance. 1 second, half a second, a quarter second, an eighth. You can keep dividing forever. There's no smallest piece of time that pops out of common sense alone. Now try to imagine all those divisions collapsing into a single instant, the very first tick of the cosmic clock. You can say the words, but you can't picture it. And that's not your fault. You're trying to use intuition built in a universe where time already exists to imagine a place where time supposedly does not. When I was younger, I used to enjoy asking simple questions that made very serious people uncomfortable. Questions like, what do you really mean by that? If someone says, the universe came from nothing, I want to know what flavor of nothing they're talking about. Is it the nothing in an empty box? The nothing before a thought pops into your head, or a nothing that somehow contains laws, equations, and the potential to explode into galaxies? Because that's not nothing, that's a very busy something wearing a clever disguise. The phrase, the beginning of the universe, sounds like common sense, but it hides a deep confusion. Beginning is a word that belongs to stories told inside time. You begin a sentence, you begin a trip, you begin a lecture and hope people are still awake at the end. But time itself is not a character inside its own story, or at least, not obviously. So when we say it began, we may be stretching language past its breaking point. Now don't misunderstand me. I'm not saying the Big Bang is wrong. Far from it. I'm saying it's incomplete in the same way Newton's laws were incomplete. They worked beautifully until they didn't. And when they didn't, we didn't throw them away, we learned something deeper. What fascinates me is that the more honestly we look at the Big Bang, the less it behaves like a beginning and the more it behaves like a signpost. A marker saying, up to here. Our current ideas make sense. Beyond this, something new is going on. And whenever physics hits one of those signposts, history tells us we're on the verge of a bigger idea, not the end of inquiry. So the real question isn't what happened at the beginning of the universe. The real question, the dangerous one, is why do we think there had to be a beginning at all? Once you let that question in, it doesn't sit quietly. It pokes at your assumptions about time, and what it even means for something to exist. And that's where things start to get interesting. Shall we keep going? Good. Because once you stop demanding a ceremonial beginning, the universe loosens up and starts to behave in ways that are much more fun to think about. Let me try an analogy, not because analogies are true, but because they're useful when the truth is shy. Imagine you're reading a mystery novel, and halfway through you get obsessed with the first page. You keep asking, yes, yes, but what happened before the first sentence? And the author says, nothing. That's where the story starts. Now that's fine for novels. The author gets to choose. But nature is not an author. Nature doesn't care where you'd like the story to begin. It just does what it does, and we come along later trying to tell a coherent tale about it. So maybe the universe is less like a novel and more like a pattern, something that has structure without needing a ceremonial opening scene. Think of a circle. Where does a circle begin? You can put your finger anywhere and declare, it starts here. But that says more about your finger than about the circle. Time might be like that, a shape we're moving through, not a line with a clearly labeled starting gun. Here's another little experiment. Picture an expanding loaf of raisin bread in the oven. This is an old favorite because it refuses to behave intuitively. As the bread rises, every raisin sees all the other raisins moving away from it. No raisin is at the center, yet expansion is happening everywhere. Now imagine you're a raisin and you rewind the process. Everything gets closer, denser, hotter. Eventually, all the raisins are practically on top of one another. But notice something subtle: the recipe for the bread, the rules that tell it how to rise, were already there. The expansion didn't create the rules governed the expansion. That's a clue. When cosmologists talk about the early universe, they're describing a state, not a magical act of creation. Hot, dense, rapidly changing, that's a condition like water boiling or iron glowing. And just as boiling water doesn't require the universe to have started boiling for the first time ever, a hot, dense universe doesn't automatically mean it was the first moment of existence. Now let's get a little more mischievous. Suppose I ask you, what's south of the South Pole? You can walk south for a very long time, but eventually the question stops making sense. Not because there's a wall there, but because south is a direction defined on the surface of the Earth. At the pole, the rule itself runs out. Some physicists suspect the Big Bang is like that. Not a moment when something popped into being, but a place where our usual way of labeling time breaks down. You see, time in physics isn't just a ticking clock. It's tied up with motion, change, and relationships between things. If nothing changes, time is a very slippery concept. In the extreme conditions near what we call the Big Bang, change itself becomes ill-defined. Distances shrink, energies soar, and the neat separation between cause and effect starts to blur. Asking, what happened before, may be like asking, what's north of north? A grammatical question with no physical content. That doesn't mean nothing was there. It means our language is failing us. Let me make it more concrete. Imagine a pendulum swinging back and forth. Time is easy to define because there's a rhythm, tick, tock. Now imagine the pendulum slows down until it barely moves. At some point, asking how long one swing takes becomes meaningless. The motion that defined time has disappeared. Near the Big Bang, all our familiar clocks, atoms vibrating, particles oscillating, stop behaving in familiar ways. So we extrapolate our equations backward, like accountants working from incomplete receipts until the numbers stop making sense. And when the numbers stop making sense, we slap on the word beginning and hope no one asks follow-up questions. But curiosity, fortunately, has terrible manners. There's another analogy I like because it makes people uneasy in a productive way. Think about temperature again. There was a time when physicists thought you could just keep cooling things down forever. Then they discovered absolute zero, a limit, not because nature ends, but because the rules change. You can approach it, but you never quite get there. Now imagine time has something like an absolute zero. The Big Bang might be the limit of how far back our current description can go, not the moment when reality itself switches on. This way of thinking opens the door to all sorts of possibilities. Maybe the universe existed in some form before the hot, dense phase. Maybe time behaved differently. Maybe the universe cycles or bounces or does something so strange that our word before doesn't apply cleanly. I'm not telling you which is right. If I knew for sure, I'd be out of a job and probably very confused. What matters is that physics allows these questions, even encourages them, once you stop treating the Big Bang like a divine punctuation mark. Here's the funny thing: people often say these ideas are philosophical, as if that's an insult. But every time physics outgrows its equations, philosophy sneaks back in through the cracks. Not to replace experiments, but to remind us what questions are worth asking. Did time begin? Is not poetry, it's a technical question about what our theories are allowed to say. And there's a personal angle to all this, too. We humans love origins. We ask where we came from, where life came from, where ideas come from. Beginnings feel safe. They make the universe feel manageable, like a story with a clear opening chapter. But nature has never shown much interest in comforting narratives. It prefers consistency, elegance, and the occasional practical joke. So if the Big Bang wasn't the beginning, what was it? Think of it as a transition, a dramatic one, certainly, but not necessarily the first act. Like the moment water freezes into ice. Something changes character, new rules become useful, old descriptions fail. But water existed before it froze, and it didn't need a cosmic birth certificate to do so. As we keep peeling this back, we're going to run into ideas that feel deeply counterintuitive, ideas where time can stretch, fold, or even lose its meaning altogether. And that's where the real trouble starts, because the universe turns out to be far less concerned with our intuitions than we are. If you're ready, we can push past the analogies and poke directly at the strange principles hiding underneath all this, where equations start whispering things that sound almost impossible, yet refuse to be wrong. All right, now we have to be brave, because this is the point where intuition starts slipping on banana peels, and instead of apologizing, physics grins and keeps walking. Let's talk about equations, not in the sense of writing them down and scaring people away, but in the sense of what they're trying to say. An equation in physics is not a commandment from the universe, it's a compressed story. And like any story, it only works within a certain setting. Use it outside that setting, and it starts saying nonsense with great confidence. Take Einstein's equations for gravity. Beautiful things. They tell you that space and time are not rigid backgrounds, but flexible, stretchable participants in the drama. Matter tells spacetime how to curve. Spacetime tells matter how to move. It's a wonderfully democratic arrangement. But if you push those equations too hard, if you cram too much energy into too small a region, they go wild. They predict singularities, places where density, curvature, and all the numbers you care about shoot off to infinity. Now here's the key point people miss: singularities are not things. They are not objects sitting in the universe. They are signals, red warning lights blinking. The model has left the building. When your car's speedometer spins wildly and pegs itself, you don't conclude the car has achieved infinite speed. You conclude something's wrong with the speedometer. Yet when Einstein's equations peg themselves at the Big Bang, we're tempted to say, yes, the beginning of everything. That's taking a broken measuring stick and declaring it a discovery. Why does this happen? Because Einstein's equations treat spacetime as smooth and continuous, like a calm ocean. But the universe, when examined closely enough, is jittery. At very small scales, quantum mechanics barges in, waving its arms and insisting that nothing sits still, not even empty space. Energy fluctuates, fields wiggle, certainty evaporates. And here's the trouble: we don't yet have a complete theory that combines quantum mechanics with gravity. We have excellent partial stories, but no final script. So when we rewind the universe to earlier and earlier times, we eventually reach a regime where we're using smooth, classical equations to describe a world that's anything but smooth. That's like using a map of highways to navigate the inside of an atom. The failure is not surprising. The surprise would be if it worked. Now let me tell you something counterintuitive, because that's where the good stuff lies. In quantum physics, the idea of a single, well-defined history starts to wobble. Particles don't have just one path. They explore all possible paths. They don't wait politely to be observed before existing, but they also don't commit to a single story until forced to. The universe, at its deepest level, is less like a marching band and more like a jazz improvisation. So what happens to time in a quantum universe? Well, time in quantum mechanics is a funny character. It's not an operator like position or momentum. It's more like an external parameter, a bookkeeping device. But when spacetime itself becomes quantum, that bookkeeping device starts to smudge. The distinction between before and after can blur, not because the universe is confused, but because our categories are too coarse. Some approaches to quantum gravity suggest that time, as we experience it, is not fundamental at all. It's emergent, like temperature. Temperature is not a property of a single molecule. It's a collective description that only makes sense when you have many of them. One molecule doesn't have a temperature, a crowd does. In the same way, time might only make sense when the universe is large, smooth, and well-behaved. Near the Big Bang, if we insist on calling it that, the crowd thins out and time loses its authority. This leads to a deeply unsettling possibility. The Big Bang may not be a moment in time. It may be a boundary between regimes where the concept of time itself changes meaning. Not a beginning, but a phase change in how reality organizes events. Now, if that made your head tilt slightly, good. That's the appropriate physical response. Let me ground this with a simpler example. Think about sound. Sound is a wave in air, no sound. Asking, what did the sound do before there was air, is not a profound mystery. It's a category error. Sound didn't exist as a thing before air, but that doesn't mean nothing existed. It means the description, sound, no longer applied. Time might be like that. Asking what happened before time may be as misguided as asking what music a rock was listening to before radios were invented. And yet, and this is crucial, physics doesn't throw up its hands here. It keeps going. It asks what replaces time when time breaks down. Some theories suggest that instead of a single timeline, there's a more abstract structure relationships between events, correlations without a global clock. In those pictures, what we call the Big Bang is not the start of everything, but the point where one particular way of ordering events becomes dominant. There are even models where the universe doesn't start but bounces. It contracts, reaches an extreme state, then expands again. To inhabitants on one side of the bounce, it looks like a beginning. To the universe, it's just another transition. The equations don't mind. Only our storytelling instincts protest. What's delightful about all this is that the universe seems perfectly comfortable without a preferred origin story. It doesn't insist on a first cause in the way our philosophy textbooks do. It's content with consistency. If the rules work everywhere they're supposed to work, nature shrugs and moves on. This is where people often try to sneak in metaphysical answers, something from outside physics to explain why there's something rather than nothing. But physics, at its best, resists that temptation. Not because the question is illegitimate, but because answering it prematurely shuts down better questions. The history of science is littered with final answers that turned out to be placeholders for deeper ignorance. Here's a thought that still amazes me. The universe doesn't need a reason in the way we need reasons. It doesn't need motivation or intent. It only needs to be consistent with itself. And consistency, it turns out, is a surprisingly powerful constraint. Given a small set of rules, enormous complexity can unfold without any guiding hand. So when we say the Big Bang was not the beginning, we're not diminishing its importance. We're elevating it. We're saying it's a clue, a glimpse of a deeper layer of reality where time, causality, and existence itself are not quite what we think they are. And once you accept that you're forced to confront a question that's less about cosmology and more about us, if time is emergent, if beginnings are local stories rather than universal facts, then what does that say about our place in the universe and about the way we understand our own lives unfolding moment by moment? That's where things stop being merely strange and start being quietly profound.